Hello and welcome. Uh, my name is Redstone MC 2003 and welcome back to the Kotlin Explored series. So today we'll be doing a video on a program that I written um, following a YouTube tutorial series. This YouTube is known as RyiSnow, so I will showcase his channel a bit. RyiSnow cookie clicker. This is his video series. Yeah, this is the and this I followed his all his YouTube series. I have translated his Java code into Kotlin and also some parts of Kotlin, and that I got help. I asked ChatGPT to help me improve the Kotlin code a bit. So yeah, I will provide the link to his YouTube series in the description down below. So let me start at the repository. So the repository is this in this link. You can search it, or I'll put it in the link in the description down below, and you can go and look for yourself. So I will um, basically clone this project into my machine and run it and explain the program a bit and maybe showcase what's working under the hood in this project. So let's go. So we open our IDE IntelliJ. I have previously cloned it, but I'm gonna clone it again. So we go to the clone repository, and then we can click the URL, and in the URL we paste our link and we clone it. And also, if you want to save it in a different location, you can do that. No, you can save it to whatever the fuck you like, it doesn't matter. So anyways, I'm going to do the next step, which is the clone. And then when we're done cloning, it will straight away show you this screen, and in the screen we can read the readme. The readme will show this. Anyways, we're not going to focus on the readme. We will anyway focus on the program in mind. So the program will be stored in the source directory, and in the source directory it's in a file called program.kt, and the reference image used by the program.kt is the cookie png, and you can see this for yourself. It's a cookie png. So in the program.kt we'll open it, and here in the program you can see in line 1 are the import statements. All of these are calling Java Swing library and Java AWT, which is also another library which Java Swing uses to implement GUI systems. I don't believe the GUI is immediate UI. I don't know. I would love to know that. If it is immediate UI, that would be very nice and very innovative for Java back then. So anyways, let's get started. So we will start at the entry point of the function of the program, and the entry point is the function main. It's anyway in our ID it's indicated by the uh, the play button, the green play button. So within the main function, there is a call to a class called cookie main, and it just calls this class like something like a function. It behaves something like a function. It just calls this class called cookie main, and within the cookie main class, um, we have some variables, and the variables, um, so variables, um, we have some variables where like from line 22 to line 44, so around 22 variables we have. So not 22, subtract 2 spaces, 20 variables. 20 variables, we have 20 variables. um, so these variables are by default assigned to a value. These the in the by this is what I'm talking about. So why do we need to assign values to variables? Well, that is because Kotlin has a thing called initialization before use, and you need to initialize a value before using it, otherwise the compiler will complain. Yeah, so we cannot have empty values. So I believe another way of like representing, like you can say int timer speed, we can represent this like this, because the IDE has recommended the delegates dot null, and we infer the um, generic type to int. And yeah, so this the compiler knows this is an int variable and it's not null, and compiler will do something in the delegates. So this is a class, this is the one of the Kotlin standard library uh, classes, I believe. It's a singleton. Yeah, it's a class. Yeah, and also why we have late init as a keyword, because well, as I mentioned before, initialization before use is a thing. So late init var means we're telling the compiler I have a variable that is mutable, and that has been inferred a type. So this thing infers a type, not infers type, sets the type, sets the type. So when you set the type, uh, this compiler knows the type, and the late init means we can tell the compiler, even though this is empty, I will promise to set a value to this. If you don't set a value to it, the compiler will complain. Like it'll literally complain. Yeah, so anyways, so the next line is the constructor, and this is a way we set constructors in Kotlin. That's one way to set a constructor in Kotlin, and also there's another way to set a constructor in Kotlin. You can do it through here, and this will by default behave something similar to this. And also um, in Java, like if you remember, you can do like public cookie main and then like this, and then the cookie main like that, and then you write this dot x whatever the thing in Java, you write in Java, so like that. So that will in Kotlin, that behavior is mimicked through here. You can write val x equals val x is of int, and it does that. uh, it does that. So this is known as the primary constructor in Kotlin. So what I have defined here is known as the secondary constructor in Kotlin. And in this secondary constructor, we have a function create font and create UI. Yeah, we call these two functions. So these two functions. So I will explain the create font function. So the create font function will we assign the two initialize the two font variables with the constructor calls to the font class, and the font class will have a comic sans ms font type, and we set the style of the font to be plain. It can be any type. It can be bold, like it can be anything. Like we set it to plain because it's the basic looking font. We want the basic font, not any stylization or whatever. Yeah, and we can set the size of the font. Yeah. So yeah. So now we move on to the create UI one. So, and here's another concept that Kotlin introduced. It's called immutable variables. So in how we represent immutable variables is via the val keyword. So immutable variable meaning, so we provide a value to the variable, and that value won't get mutated, but mutation can happen in I believe another way values can get mutated is through a concept called shadowing. I believe I read it through some compiler books I've read through. Like, yeah, so I believe it's called shadowing for immutable variable. So for things which are immutable, like to set a different value, it's shadowed, like something like that. So yeah, so in here we can do a dot operation, and we can call a function or a property. So in here, this is, even though it's a property in Kotlin, in Java actually this is a function. It's actually a function. Kotlin just simplified it by making it a property. That's how, like, this is how the modern Kotlin works. This is actually a static file int, but this is looks like an enum. If you are familiar with enums, it behaves like an enum. So why we set this layout to null? Because Java Swing has different layout types, which is grid layout and and I believe this is a linear layout. So we set this to null because we don't want anything, so we can just set the position to whatever we like and whatever. This window the title, meaning we set the title of the window. It's like basically something similar to this, like in let me okay, so sorry for this cut. So anyways, I want to explain the title of a GUI window. So basically this the title meaning the Windows title would be this. So yeah, so in our program we have set the title to cookie clicker Kotlin, and the in here we have set the content pane to background to the color of black. That means the window will be initially white by default, but we have set the background to be black, so that it becomes black. And we have set the default close operation to exit on close, because Java JFrames don't know how to close. Like Windows actually don't understand um, that you're actually being closed, because it needs an operation to register that it's being closed. So I will explain the next part, which is the panel type, which is the JPanel. So in here we have variable cookie panel, which infers of the type JPanel. And yeah, type inference in Kotlin is actually represented by a equals sign, not this which you see in Golang. And of course no val keyword, but this is more nicer, I believe. My opinion is biased, but it's whatever. Set bounds starts the x coordinate at 100 and starts the y coordinate at 200, and the width and the height is 360, so it's going to be a square. So what that means, setting the boundary, so I believe, so in the coordinate system of a window, so a window normally starts at this position, which is the point 0 0, and x would be to the right position and y would be the down position. Sorry. And x 100 y 200, meaning it can be here. Let's assume this is the coordinate x 200 x 100 y 200, and width and height 360, meaning the length of the um, boundary is going to be 360 from the x, and the height of the length is actually the, in this case length is same, so yeah, so it's gonna be 360 by 360, so x 3 and move by 360. That means our final coordinate here would be like around 460, and our y coordinate here would be around 560. And yeah, and then the Java swing would know the plotted points. Yeah, so that's basically the boundary of the panel. That's how the panel works. And okay, so we have set the background property to color of black. This looks like an enum. It looks like an enum, but it's not an enum. It's actually a public static int final. Yeah, yeah, it is. No, it's an enum actually. Yeah, it's an enum. Yeah. So anyways, window.admin, we need to add this to be shown on the panel itself. So the cookie, which is an image, inverts the type of image icon, which takes a directory path of the source cookie png, this thing. and that's how we load images. Otherwise you would have to do something like java class dot get resource, something like that, in Kotlin. Like that's how you call the java class thing. Otherwise in java you would have to like get resource dot something like that, like this, something like that. Yeah, I don't remember, but it's mentioned in RyiSnow's video. And here we have a cookie button, which is of the J button type. And I will not explain this. I hope the code is a little bit explanatory, but I will explain the action listener. The action listener is like it, like cookie a button does a certain action. So the action is handled by a C handler. A C handler is our uh, inner class, which I will mention later. The inner class that does uh, some operations for the button. And here is a J panel. I will not explain that. I will just move on to the next one. I will show you a cool thing in that Kotlin has that Java doesn't have. It's the strings. The strings in Kotlin are very nice, and like it's like behaves similar to string templates, but it's not in a way. It's like it's a pretty cool feature. So this dollar sign means you can access a variable or a class. I can show that. We can do something like java class dot, we can do to string, and we can do a function. We can do like cookie mean, like that, something like that, like yeah, not the class name itself. Yeah, no, we can do the class name itself. Oh, yeah, yeah, yeah. Okay, so let's move on. Yes, and also the by default Java windows are invisible. So to make them visible, you need them to true. And let's move on. So the next function is a timer, and the timer is, we have a timer class actually. So the timer variable is calling the timer class. And here, look at this cool thing. This is like a lambda in Kotlin. So it's like a it behaves like a lambda. uh, I I'm sure this, it looks more like a scope to me, but I think this is a lambda. I'm sure professional Kotlin developers know this feature very well. It's a cool feature, I believe. Very nice feature. So like no arguments, we provide no arguments. We can do this, and then we provide the function operations, and the function, whatever the function does, it executes. So that's cool. Now we go to the next one, which is the timer update. This is the logic to update the timer variable. No, yeah, timer variable. The next one, as I mentioned, is the inner class, which implements a action listener interface. And this interface, by default, we need to override it to for provide actions the functions. And inner class in Kotlin is like, it's like It looks like this in Java. It's like looks like this in Java. Like this, something like this in Java. Oh, sorry, it should be class here. Like that, it look like that in Java. The inner classes, but in Kotlin it provides a nice keyword called inner, and that tells the compiler that this is an inner class. So in Kotlin, we don't have a switch statement. We have what it's called a when statement, and this behaves similar to the switch statement, except I believe this has pattern matching in it, also pattern matching capabilities. Uh, so yeah, this is like similar to the switch statement. So there's nothing exciting to explain about the switch statement. So yeah, let's move on. Yeah, so I guess that's it for today. Like, that's all the code. So it's about 158 lines of code, and we can now run the program and see what's the output of the program. Yeah, so this is what the program looks like. When we hover, we can see some cool data being represented, and we can see this. And by the way, this is a button, so when you click on it, it just does this. So let's get to 100 cookies, and let me show you something cool that we have implemented from the tutorial series. Oh yeah, this should, yeah, okay, now it worked. The grandpa is shown, and now you can see due to the timer function, the counter of the cookies has incremented. And yeah, so that's it for today. So that's done. So in Kotlin, it will generate a class file. So we want to look at the deconstructed assembly from that. So we will cd into the out file slash the production slash the cookie clicker. And then we do java b dash c dash v dash the class name. The Java P is a program that Java provides by default. This will decompile the class files and give you assembly output. So yeah, no, not actual assembly. It's like the Java assembly actually. The assembly which is understood by the virtual machine. So the dash C is the flag, which I don't remember. Dash V means it's give provide verbose. So when we execute this, we'll see a bunch of data. Okay, so in the beginning we get a checksum which is of SHA-256. I don't really care about this checksum. We can put it on the internet or whatever, and it'll say compiled from program.kt. That's the file name. And it'll say mine version 0, major version 52, which means this is the bytecode version. And in our Kotlin decompile class, it says 52, which is of Java 8, which is um, what I believe the Kotlin has decompiled into Java 8 bytecode, which I believe many companies use still to this day, not Java 24. Yeah, but Java 8, I believe it has a lot of features. No, no, not a lot of features. No, sorry. Yeah, anyways, so here are some flags. This class, superclass, and interfaces, fields, methods, and attributes, and it'll have a constant pool. Majority of the constants are UTF-8. And here at line 25 we have a Unicode string of data, and here is the public static final void main. um, in here we can see the stack trace of the compiler. Yeah, the compiler has two versions. There's an interpreter stage and there's the compiler stage. If you learn Java, you know this. uh, I might get it wrong. I am a little bit rusty in Java, but yeah, from what I remember, that's what it does. And here is again some assembly, and here is the metadata uh, that the compiler knows. So here, as before, we have the Unicode string right here, and yeah, so that's it for today's video. uh, Thank you for watching, and for the next video I will be describing the main function under the hood, and tell you why it's the most beautiful function in this programming language. So thank you for watching. Have a nice day, and please put your comments, and I would love to listen and hear some advice from you. Please correct me if I'm wrong, and other than that, good day. Bye bye.